Alright, so this is section 6.13, which is on power. So let's first recall the type 1 and type 2 errors. So type 1 error is when H0 is rejected at the list level, but it's true. And type 2 error is the opposite, which means when H0 is not rejected at this level, but it's actually false. Okay, so in the previous section, we know that the probability of type 1 error is always less than equal to alpha, which is the significance level. So today we're going to talk about power. Power is equal to 1 minus the probability of type 2 error. And some book calls probability of type 2 error beta, the letter after alpha. So because the power is 1 minus probability of type 2 error, so the higher the power is, the better the test is, because that means the smaller the type 2 error is. Okay, so let's talk about how to calculate the power. So to calculate power, first we find the rejection region. And then second, find the probability that a value falls in the rejection region under, this is important, under the alternate distribution, which we'll talk about what it is in next page. Okay, so let's do a concrete example. So let's consider the null hypothesis is mu less than or equal to 80, and the alternate hypothesis is mu greater than 80, and alpha is 0.05, sample size is 50, and standard deviation is 5. So with all these, we can draw a null distribution. So the null distribution has mean 80, and variance is the original variance divided by the sample size. So the standard deviation is 0.707. Okay, so we can draw the null distribution. Mean is 80. So the trick to calculate power is we need to propose a specific alternate value for the alternate distribution. So if we look at the alternate hypothesis, that means mu is greater than 80. We need to pick a value that's false in this hypothesis and form an alternate distribution. So in this case, let's choose mu to be 81, which is greater than 80. So if mu is 81, then the alternate distribution will be the normal distribution with mean 81 and the same standard deviation as the null distribution. So this is our alternate distribution. Alright, so to calculate power, first we find the rejection region. Technically, we first find a critical number, which is about here. So the critical number, or critical point, is because alpha is 0.05, so the critical point is the value that leaves the tail equal to which has the area 0.05. So the critical point gives you the z-value equal to 1.645. That leaves you 0.05 at the tail, which means the critical point has value 80 plus 0.707 times 1.645, which is 81.16. Okay, so that's the critical point. So the rejection region is everything to the right of the critical point. It's everything to the right of the critical point. Okay, so now all we need to do is calculate the area under the curve to the right of the rejection region, in the rejection region. So it remains to calculate the area of this thing. That's going to be our power. So power is going to be the area of this thing. Okay, so to calculate power, we now calculated the z-score corresponding to 81.16 under an alternate distribution. So the z-score is 81.16, but now this time we subtract 80 and divide it by 0.707. So this is equal to 0.23. So the two z-scores are different. The first z-score, this is under no distribution, and the second z-score is under alternate distribution. So be careful. And then because the z-score is 0.23, if we look at the table, the power is equal to 0.4090 according to the table. So this is the power. And because the power is so low, this is too low. So that means the test is not good. Has a high chance of making type 2 error. All right, so let's do a slightly different example. Most of the numbers are gonna stay the same. So let's do this. So let's do a slightly different example. The null distribution is still mu less than or equal to 80. Same with alternate distribution, mu greater than 80. Alpha is still 0.05. Sample size still 50, and standard deviation is still 5. So that means the null distribution is still the same. So the null distribution is still has mean 50 and the standard deviation 0.707. But in this case, let's choose the alternate distribution to be mu equal to 82. So in the previous example, we chose 81. So now let's try 82 instead of 81 and see what happens. So mu is 82. So the null alternate distribution is normal distribution with mean 82 and standard deviation. Standard deviation is the same thing. Okay. So now the alternate distribution is a little further away. Oh, sorry, this is 80. And this is 82. And because the null distribution is the same, so the critical number is still the same. So it's about here. So the critical number or point, it is still 81.16. But so the rejection region is still this green part. Yep. But the power is different because the alternate distribution is different. So the area of the tail, well, not so much tail anymore. The power is the area of this part. So power is equal to this area. So to calculate the area of that part, we calculate the z-score. So the z-score is 81.16 minus 82 divided by 0.707. 0.007. So this is equal to negative 1.19. So if you look at the table, the area to the right of negative 1.19 is equal to 0.8830. So this is our new power. So which indicates with the alternate distribution mu equal to 82, the power is way higher. So this test is way better. All right.